Have you ever imagined living on another planet? What if there were Earth-like worlds out there, orbiting distant stars? Worlds that could support life just like ours. Welcome to Fact or Theory, the channel where we explore the mysteries of science and the wonders of our universe. If you're fascinated by space, exoplanets, and the possibility of life beyond Earth, you're in the right place. Introduction. What does it mean for a planet to be habitable? Imagine a world where a planet has the perfect conditions to host life. It all starts with the idea of the habitable zone. The habitable zone is the distance from a star where temperatures are just right for liquid water to exist. Water is essential because it's a key ingredient for life as we know it. Too close to a star, and the water would boil away. Too far from a star, and it would freeze. The habitable zone keeps everything balanced. It's often referred to as the Goldilocks zone, not too hot, not too cold, but just right. This is where scientists believe life could thrive, but habitable conditions depend on more than just being in the right spot. It depends on the planet's atmosphere, its size, and its overall climate stability. Habitable zone. The concept of the habitable zone leads us to understand the types of planets that could support life. Not all planets are equal when it comes to habitability. Some are gas giants, massive and unsteady. Others are rocky planets, much more promising when it comes to supporting life. Earth-like rocky planets are better candidates for hosting living organisms. They can have stable surfaces, oceans, and atmospheres, key ingredients for life as we know it. Think about Earth's structure: rock, liquid water, and the right balance of gases in the atmosphere. That balance allows for the development of ecosystems and the conditions necessary for living things to thrive. Scientists believe rocky exoplanets in the habitable zone may mirror Earth's potential conditions. Their discovery is one of the most exciting parts of modern astronomy. There are already many exoplanets being studied with the potential to resemble Earth. Some of these planets are just larger or smaller than Earth, but could have similar conditions. The search is ongoing, and each discovery brings new possibilities. Exoplanets. Now let's take a closer look at some of the exoplanets that scientists believe could support life. Kepler-22b is one of the most well-known examples. It's located in the habitable zone of its star and has a size that suggests it could hold liquid water. Another exciting find is Kepler-442b. This planet is rocky, similar in size to Earth, and also located in its star's habitable zone. Proxima Centauri b is another promising candidate. It orbits the closest star to our solar system and is within its star's habitable zone. This makes it one of the most intriguing planets in the search for alien life. All these planets are exciting because they share similarities with Earth's size, temperature range, and other conditions. However, we must study their atmospheres and other factors to confirm their potential for life. The discovery of these planets relies on advanced telescopes and space observatories. Each discovery brings hope that we are closer to finding an Earth-like world capable of hosting living organisms. These exoplanets are just the beginning. The search continues, with new missions and space telescopes aiming to uncover more possibilities. Key factors when searching for habitable planets. Scientists focus on several key factors. One of the most important is the presence of liquid water. Water is essential because it's a building block for all known life. Without it, life as we know it cannot survive. A stable atmosphere is another crucial factor. It protects a planet from harmful radiation and helps maintain a stable climate. A planet's atmosphere must have the right composition of gases, such as oxygen and carbon dioxide, to support life. The planet's size also plays a role in determining its habitability. Planets that are too small may not have enough gravity to retain their atmosphere. On the other hand, very large planets may not have solid surfaces, making them less likely to support life. Scientists also study a planet's climate stability and its ability to maintain consistent temperatures over long periods. Temperature changes could prevent the development of stable ecosystems. All of these factors come together to determine whether a planet could support living organisms. The search for exoplanets involves analyzing these criteria in combination. Each discovery offers new clues about which worlds might be capable of hosting life. Role of technology. Now let's talk about the role of technology in discovering these potential habitable planets. Space telescopes like Kepler and TESS have revolutionized our search for exoplanets. Kepler was launched in 2009 and discovered thousands of exoplanets in the habitable zone. TESS, the Transients Exoplanet Survey satellite, has continued this mission by scanning the sky for planets passing in front of their stars. These missions rely on a technique called the transit method. The transit method looks for a slight dip in a star's brightness as a planet crosses in front of it. This allows scientists to identify potential exoplanets. Other methods include radial velocity, which measures the gravitational effect of a planet on its star, and direct imaging. Direct imaging allows us to capture pictures of distant planets by blocking out the star's light. The James Webb Space Telescope is another groundbreaking mission. It allows astronomers to study the atmospheres of exoplanets in incredible detail. With this technology, scientists can detect the presence of gases like oxygen, methane, or water vapor, signatures of potential life. The combination of these advanced tools has allowed us to find promising candidates for habitable worlds. Technology is not just helping us discover these planets, it's also helping us determine if they could host life. The next generation of space missions will give us even more opportunities to explore these possibilities. Possibility of life. While the discovery of exoplanets is exciting, we must also consider the possibility of life itself. What would life on another planet look like? Could it be similar to the life we have on Earth, or could it be entirely different? Scientists focus on the idea that life depends on certain key ingredients. These include liquid water, the right chemical elements, and energy sources like sunlight or geothermal heat. When searching for life, astronomers study a planet's atmosphere and surface for signs of these ingredients. For instance, the presence of oxygen and methane in a planet's atmosphere could indicate biological activity. On Earth, oxygen is produced by photosynthesis, while methane is a byproduct of biological processes like digestion. These chemical markers are used as biosignatures, evidence that life might exist. Exploring moons in our solar system, like Europa and Enceladus, is another way scientists are searching for life. These moons have vast oceans under their icy crusts, powered by tidal heating, which could support life. Exoplanets may also harbor life in environments we can't easily imagine. Life could exist in extreme conditions, underneath oceans, in rocky atmospheres, or even in gas giants. The discovery of alien life would completely change our understanding of biology and our place in the universe. We are still in the early stages of this search, but every discovery brings us closer to answering this age-old question: are we alone in the universe? Planet's atmosphere. The discovery of potentially habitable planets and the search for life raises another fascinating idea: the effect of planetary atmospheres. A planet's atmosphere plays a vital role in determining whether it can support life. It acts as a shield against harmful radiation and helps regulate temperature to create stable living conditions. Earth's atmosphere, for instance, is composed of nitrogen, oxygen, and small amounts of carbon dioxide. This unique mix allows Earth to maintain the right climate for life. When studying exoplanets, scientists look for planets with similar atmospheric compositions or the presence of biosignatures. Biosignatures are chemical markers that suggest the presence of biological activity. Oxygen and methane, when found together in an atmosphere, could indicate the presence of life processes. However, other factors, like volcanic activity or chemical reactions, could mimic these signals. That's why analyzing the atmosphere of a planet is complex and requires advanced technology. The James Webb Space Telescope and other advanced observatories are at the forefront of this analysis. By studying atmospheres, scientists can narrow down which planets are most likely to host life. It's a critical piece of the puzzle in determining the habitability of exoplanets and whether they could be homes for alien organisms. Understanding a planet's atmosphere could ultimately give us clues about its potential for long-term biological processes. Planetary effects. Now let's explore the idea of planetary effects and their connection to the concept of wake effects, or planetary wake interactions. Much like how boats create waves as they move through water, planets and their atmospheres can create patterns as they orbit their stars. These patterns, referred to as planetary wake effects, can influence climate and atmospheric circulation. For example, gravitational interactions between a planet and its star, or a planet and its moon, can alter wind patterns or even affect atmospheric composition. The effects can impact the ability of a planet to maintain stable conditions necessary for life on Earth. We've seen how ocean currents and wind patterns influence climate stability, supporting ecosystems across the globe. Similarly, wake effects on distant planets could determine their ability to retain liquid water or sustain a life-friendly atmosphere. It's an area of ongoing research as scientists try to determine how these effects shape the long-term habitability of exoplanets. These interactions can also affect how a planet absorbs solar radiation, distributes heat, and regulates seasonal climate changes. Understanding wake effects provides insight into how atmospheric and planetary behavior could impact the potential for biological processes. These subtle changes could either create opportunities for life or render a planet inhospitable. The study of wake effects is just one of many factors scientists consider in the search for Earth-like worlds. It shows just how interconnected planetary systems are and how important detailed analysis is in our quest for discovery. Planetary trails. As we explore the potential for habitable planets and the effects of their environments, we must also acknowledge one final fascinating concept: the effect of planetary trails or space wakes left behind by these dynamic interactions. These wakes can be thought of as the footprints of planets moving through their atmospheres or the gravitational effects of their orbit. For example, as a planet moves in orbit around its star, its gravitational pull can create subtle waves within its atmosphere and the surrounding space. These interactions can leave unique patterns that could impact the planet's climate, ocean currents, and even the likelihood of maintaining stable ecosystems. Planetary wakes can also serve as clues for future research missions. By detecting these signals, astronomers might identify exoplanets that could potentially host conditions necessary for life. The movement of these planets can also shed light on their orbits and the stability of their environments. Understanding these interactions allows us to build a clearer picture of how planets behave over long periods and how their climates are maintained or disrupted. As research progresses and space telescopes gather more data, these wake patterns may reveal a lot about planetary habitability and life potential. It's yet another piece of the puzzle as scientists try to uncover the mysteries of distant worlds. Exploring how these effects influence habitability is a promising part of modern astronomy. It highlights the interconnected nature of gravitational interactions, atmospheric science, and the search for life beyond Earth. Summary. Now let's summarize the key points we've explored about potentially habitable planets and the fascinating science behind them. We've looked at the concept of the habitable zone and how it defines the area around a star where liquid water can exist on a planet's surface. We've discussed the types of planets, rocky versus gas giants, and why Earth-like rocky planets are considered the best candidates for hosting life. We've explored some promising exoplanets such as Kepler 22b, Kepler 442b, and Proxima Centauri b, all of which show potential signs of habitability. We've also examined the role of technology and space telescopes like Kepler, TESS, and the James Webb Space Telescope in discovering these planets and analyzing their atmospheres for signs of life. The search for biosignatures like oxygen and methane could one day confirm whether these worlds are truly capable of supporting life. We also explored planetary atmospheres and how they determine a planet's ability to maintain climate stability and support biological processes. The idea of planetary wake effects and gravitational interactions introduces even more complexity to the search for habitable worlds. These interactions can influence a planet's climate, atmospheric patterns, and even its ability to maintain stable conditions over time. As new technologies and advanced missions continue to scan the skies, we're entering an exciting age of discovery. The possibility of finding other Earth-like worlds or even alien life remains one of humanity's most profound questions. The search is far from over, but every discovery brings us closer to answering the question: could we one day find a new home among the stars? The journey is just beginning, and the universe continues to inspire curiosity and wonder. Conclusions. Before we wrap up, let's think about what the future holds for the search for habitable planets and the quest for life beyond Earth. The next generation of space telescopes and scientific missions will play a pivotal role in shaping our understanding of these distant worlds. Missions like the James Webb Space Telescope will allow us to study the atmospheres of exoplanets in unprecedented detail. With its advanced technology, It can detect key chemical markers such as oxygen, methane, and carbon dioxide. Potential signs of biological activity. Upcoming space observatories like the European Space Agency's ARIEL mission and NASA's LUVOIR telescope could further expand our ability to detect habitable environments and trace biosignatures. These technological advances will provide clues about how planets maintain climate stability and whether they have the key ingredients needed for life. Moreover, new robotic space missions and advanced planetary studies could give us insights into the surface conditions of distant exoplanets. The study of planetary moons, such as Europa and Enceladus within our solar system, will also continue to reveal potential clues about hidden oceans and the possibility of life beneath icy surfaces. The discoveries on the horizon could lead to groundbreaking answers about our place in the cosmos. So what's out there waiting for us in the depths of space? Only time and technology will tell. Stay curious, because the exploration of the cosmos is far from over. If you enjoyed this journey into the possibilities of life and habitable worlds, make sure to like this video and subscribe to our channel for more fascinating scientific explorations. Hit the notification bell so you never miss an update as we continue to explore the mysteries of space and science together. What do you think about the search for habitable planets and alien life? Let us know in the comments below. We'll see you next time.